Okay, so consumption of alcohols, plant consumption of alcohols, and tailored to alcohols. Okay, hello folks. Hello Tadashi, Shilpa, and Dominic. Let me give you your points. Lewis, Lusha, and Stark. And who else is there? Isabella, Noah, and Nicholas. Dynamite, and I've got Merla and Sarah and Priya. Merla, Priya, Sarah. Continuing, I've also got Vincent and Lee. Hello, gentlemen. Thanks, everybody, for being here. Appreciate it here on a Friday. Happy Friday, everybody. And I've got Julian L. And I'm going to move this up a little bit. Kind of leaning over too much today. And I got Riley. Hello, Riley. We're going to kind of finish up with alcohols today. That's our goal, folks. So we've got kind of a lot to do. There's some tidbits that we couldn't finish up because we just got cut off from the end of a couple classes. So we'll try and do all that today. Hello, and there is Lily. Good. Still looking for a few others. There should be some more. I'll wait here. Some more signing on right now. Looks like I will be seeing all of you after Easter break. I don't know what that's going to look like. It might only be half of you or it might be all of you. We're unsure right now, teachers. When we know, we'll let you know, or the administration may let us know at the same time they let you know. But for sure, you'll be back in some form or other after Easter break. Good. Hello, Larissa and Thomas absent. Yeah, he wrote me. Thank you, Riley. Good. Let's see who else is there. I'm still looking for a Magdalena, a Natalie, a Julian K. I'm looking for a Lena, Deacon, Christian, and Ali. Let's see if any of those are showing up here. That would be Swelleroonie. Okay. Let me put something on the board while I'm waiting. Something, I think, from our last lab. I hope so. So here we go. We had something like this. CuO plus ethanol. It doesn't matter whether I did it this way or not. And then I said we got copper and we saw it was nice and shiny again. Plus we got something else. Well, what the heck was that? So it's this, boom, shaboom. And what happens is the O gets sort of stuck on here, so I get two OHs on the same O. O. But, and that's what I want to see if we got to today. And we'll see how far we go. In the meantime, I have a couple more that came. Very good. So, I'm guessing I've got Natalie is there. Natalie and Deacon are there. Good. Let me check you in, give you some points for being there. Mr. Deacon, Ms. Natalie. All right, still looking for Magdalena and Julian K. Lena, Christian, and Ali. If any of you are there. There's Magdalena. Very good. Soupy. Any others that are now there? Okay. All right, let's do it. Here we go. So my people, when I did this at school with you, I took a piece of copper, I heated it in a flame, and then I shoved it into some ethanol, some spiritus, right? Mostly ethanol. And here's what we decided to happen. The CuO was the black stuff on the copper when I burnt it. When I shoved it, when it was still hot, into the ethanol, suddenly it became shiny again. So it got rid of the oxygen. Where did it go? It went on to here. What did it do? It must have joined. Turns out it joins generally on the same one as the OH because this bond gets weakened. And I get the H comes off and joins here, and I get an OH. But this, with two OHs, does not exist. Why not? Who remembers? Who remembers? Did we get that far? So what's the problem with what's the problem with thank you, Tadashi's got it, as does Sarah. Right. So it's unstable. So what happens is it becomes this. I'll do this in black so it's really clear. To become stable, it does this. It goes ramp, ramp. That's still the same. But now, instead of, as Sarah just described it, I get two bonds to oxygen, and then look what comes off. That stays, but I got another OH that's gone, and I've got a H that's gone, and if you think about it, that makes something else as a side product. What does it make as a side product? So what do you suppose also comes off, even though we can't see it in the solution? What else comes off here? So that comes off, this comes off, and I'm left with the O, and that becomes, as Sarah said, a double bond O. And Sarah knows, as does Shilpa, so I get water out of this, okay? Water forms easily. That's why we have oceans of it. It's very low energy bonds, so it forms really easily. It's going to form in many, 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 many reactions you and I do this semester with organic chemicals, okay? And there's the first one today. Okay, we need to say in words again, I think, because I don't think we did it last time. So this is due to Erlenmeyer's rule. Erlenmeyer's rule. Okay, did we have Erlenmeyer's rule yet? Yes, yes, no, no. Did we write Erlenmeyer's rule yet? I think I'm going to write it again anyway because it's important. And we may need it again. Shilpa says no. Thank you, Shilpa. Okay, so let's just do it. So what is Erlenmeyer? Okay, Erlenmeyer made the flask. Remember the flask we had? The flask that looked like this? They're like a triangle shape at the bottom. Those are Erlenmeyer flask. You probably use those in chemistry. So what is the same person? What is Erlenmeyer's rule? Okay, it says that anytime two hydroxide groups we're going to start using the word groups. Don't worry, it just means like branches, okay? So anytime two hydroxide groups are on the same carbon, this is unstable. Water forms. And more importantly, a C double bond O forms. C double bond O forms. Okay, so now you have it. That's Erlenmeyer's rule. Anytime two hydroxide groups are on the same carbon, this is unstable. So water forms and a C double bond O forms. We're going to do another one like that right now. Okay. I think I'm going to jump right into this. I changed my mind because it's a natural segue. All right, folks, I'm going to scan this and send this to you. So essentially the top one we just did, but I'm going to send this to you. And the bottom one we're going to do here, and then you'll have all this, okay? All right, along with some very important vocabulary. Okay, what we made. All right, so example, our product looked like this. It's got the C's and then a double bond O. When you have this, careful now, don't put another H. Remember, it's got a double bond and it's got a single hydrogen and then another CC bond. So there's no H down there, right? This is called an alkanal. That's the German word. And in English, it's called an aldehyde. So aldehydes are a group of chemicals that have this C double bond O at the end, okay? The C double bond O has a special name. There's an H coming off there. That C double bond O is called a carbonyl group, like carbon with a YL at the end, okay? A carbonyl group. Turns out all aldehydes got a carbonyl group at the end. Aldehydes carbonyl group at end. You ever hear of formaldehyde? Formaldehyde, it's a really stinky aldehyde. Well, it's one of many that is used as a preservative. So that's the use. Preservatives. Preservatives. In German, Konservierungsmittel. So what does it mean? It means if I got like in biology, maybe you got Mr. Lee or somebody in biology, he gives you a jar with a dead fish in it. Well, that jar is full of dead fish and aldehyde or some other preservation material. Okay, but often it's an aldehyde. Could be formaldehyde or whatever. At any rate, so that's the scoop. So those are used as preservatives. Okay. So, any questions so far? We okay? Okay. What we just did was called a what do I want here? I want black. We oxidized literally added oxygen to a primary alcohol and got an aldehyde. Now, I'm not going to do the reaction. We already did it. But I do need to have you know what the heck is a primary alcohol or primary alcohol, okay? Put a little star there. A primary alcohol is pretty easy. It's got the OH on the first or last carbon. That's why it's called primary first, okay? So primary equals the hydroxyl group OH on first or last carbon in the chain. Why am I mentioning that? Because guess what? Now we're going to oxidize a secondary alcohol. So here's a secondary alcohol. Secondary alcohol. So that means the hydroxyl group is in the middle somewhere. Right? The OH, also called a hydroxyl group. Notice how I'm changing names a little bit. So in 9th grade, we call it hydroxide. In 10th, we often call it a hydroxyl group. It's the same thing. It's an OH. Don't get all disturbed, okay? Sometimes chemists use different words for the same thing. It's okay, all right? So the second, go with the flow, all right? Secondary alcohol. It's a hydroxyl group on a middle carbon instead of the N. So on a middle C instead of the N, okay? We all right? Let's do one. Here we go. So example. Okay, so C, let's take this and let's erase because I need more room. I can see that already because I write too big. But you got to see it, so what the heck? Stay there. Let's put the OH on the middle. Okay, ready? Poof. We're going to oxidize this. Literally, we're going to add oxygen, just like we did when we shoved our hot CuO into the ethanol. We added oxygen to the ethanol, and we got an aldehyde. So let's do the same thing here. Okay, oxidize. So now here's what we get. We get C, and we get our OHs here, and we get an OH here. Why does it go on the same C? Because this OH tends to be always fairly electronegative, so this bond over here was fairly weak. So that bond to the H is weak, and therefore another OH can attach most easily on there. Okay, but this molecule is what, gang? And while you're answering that, this molecule is what? Let me read a comment here from Magdalena. Is there also a differentiation between the OH on the second, third, fourth carbon? Yes, and we're not going to deal with that. Okay. All right. There are tertiary carbons, tertiary ones as well, but not in this class. Okay. Let's just do primary and secondary. If we get through that, believe me, Magdalena, life will be good enough. And thank you, Larissa and Natalie. You're right. It's unstable due to Erlenmeyer's rule. Whoop, whoop, whoop. Okay, unstable. So instead, what do we get? Well, we get the same three C's, C, you see. And on that middle one, we get now, well, here's what happens. One of these suckers, doesn't matter which one, that one goes with a H, and they go and make water. Okay, plus H2O. I don't really care about the water, but that's what forms. What's left is this. I get a double bond O, but this time it's on a middle C. And you might say, Mr. Weiss, does it really matter that the does it matter that the double bond O, the carbonyl group, the new term we had for that, is on the middle? Isn't it just the same as being on the end? No. It affects the properties of the chemical if the double bond O is in the middle, and it's a different chemical. You ready? Okay, so this sucker is now called, and I got to write it up here because I run out of freaking room. I hope you're writing all this down, but I will send it to you as well. Okay, I'll send you this document on my lap. I wrote it up years ago, and it's pretty handy. Okay, so this thing is called a ketone. A ketone, or in German, Alkanone. Guess I should capitalize it, right? Okay, so in English, ketone, German, alkanone. This one is called acetone. Okay, ours here is called acetone. And is an organic solvent. Here's what that means. It's good. Oh, I got a late start. I got Lena. Okay, Lena. All righty. You may have to watch the rest of the video, Lena, to see this because we missed quite a bit. All right. Yeah, you missed half the class, so go and watch the video for the rest of it. Okay, an organic solvent. Okay, so what a solvent is, it dissolves other organic molecules. Remember how we said like dissolves like? Well, water dissolves lots and lots of stuff that's polar. But most organic molecules are non-polar. So an organic solvent, a solvent is something that dissolves other non-polar organic molecules. And you might be saying, this is getting hard. Okay, wait a minute. I said we made this one special here is called acetone, right? So the stuff we made, this thing, that's acetone. Acetone. Acetone has a common name as an item that is often used for stuff. Okay, acetone is in, and it's the main ingredient in, ready? Fingernail polish remover. So in other words, you can go down to D&M or some other drogerie and buy acetone. It's in fingernail polish remover, okay? It dissolves the fingernail polish. Water won't do that because water dissolves polar stuff. This stuff is nonpolar. And you can tell it's nonpolar. Look how symmetric the molecule is, okay? You might say, what about the O? The O is in the middle of the molecule. It's not really able to do a lot of anything. It's not a strong enough dipole to do anything. So this sucker is mainly a non-dipole molecule, okay? If it had an OH, it could maybe do a little in the middle, but it just has that double bond O. It's not enough to make it, so it's still a non-dipole. Okay? And Larissa, I need a little more of your comment. I can't read it. Okay, try it again. Okay, all right. Good. It's okay. All right, so let's go on and oxidize something again. We okay? Any questions about what we're doing here so far? One of the goals of this course is for you to be able to write and think about organic reactions. We just did one. When we added oxygen, oxidized something, we added oxygen to a molecule with an OH, a hydroxyl group in the middle. We got two of them, and that became then this stuff, acetone. That's an organic reaction, isn't it? Let's do another one like this, okay? All right, here we go. This time I want to start with an aldehyde. So we're going to oxidize an aldehyde. Okay, here's our aldehyde. Let's use the same one. Oh, let's use a different one. Here, let's use this one. All right, so you know it's an aldehyde because it's got the double bond O, C double bond O. That's called a, whoops, too many H's, sorry. C double bond O. That's the carbonyl group. It's got that at the end, okay? And this particular one is called propane. From propane, remember? That's three C's, right? Propanal. Ah, where's the al come from? Because it's an aldehyde. See, it's not so hard to name these, is it? So that's a propanal, right? You can call me Al. You can call me propanal. Okay, now we're going to oxidize this sucker. Ready? Oxidize. You might say, but we already did that. You're right. We're going to do it again. Oxidize again. And we're going to get something else. And it's going to look like this. So boom, boom, boom. There's my three C's still, the propyl base. Well, it turns out if I keep oxidizing, I get another OH that attaches on here at the end because it's got nowhere else to go. And then I got the C double bond. O is still there. So now I got a big old sucker at the end. I got a C double bond O and OH. This thing, lots of new vocabulary today. This thing's called a carboxylic group. Carboxylic group. You might say that's the same as the carbonyl. No, it's not. The carbonyl is this, but if I add a OH, now it's called a carboxylic group. Lots of new vocabulary. Okay, I got a question from Lee. Let me stop and see what's going on. Okay, Lee asked about how I knew where the double bond O goes. Because I get to pick, because I'm the teacher. In other words, Lee, I don't expect you to know that. Okay, you don't have to know that. What you do have to know is, Lee, if you get one where the double bond O is at the end, then this thing can happen. Turns out, if the double bond O is in the middle, going like up or down here, Lee, this reaction won't happen. Okay? So I'm doing the reaction, which is the only one you got to worry about in terms of a aldehyde changing to this thing, which we haven't told you what that is yet. Well, it turns out Turns out, if I got a C double bond O at the end, it's an acid. It's an organic acid. Organic acid. Now, some of you had acids with me last year. They give off an H plus, don't they, in water? This is a fairly weak one, but the H plus that comes off is this one up here, up at the top, okay? You don't have to worry about that now. We'll deal with that another day. For now, you need to know it's an organic acid. You ready? Here's the name. This one is called propan. Well, of course, 3 C's, right? Propan. Ready? Propanoic acid. The word acid tells you it's an acid, and so does the oic. So it's got 2 indicators to tell you an acid. So to make a short story long, which I already have, and I'll answer your other questions in a second, I promise. So an oxidized aldehyde or alkanal, if you want the German, makes an organic acid. And so an oxidized aldehyde, that was this sucker, that was my aldehyde. Propanol is an aldehyde. And there's my organic acid, the thing I made here. When I put more oxygen on it by whatever method that we have. Okay, let me read some questions now and see how you're doing. Okay. Okay, so I got to read Lily's question here. Sorry, my eyes are not so perfect today. So when you add an OH, it goes from being a hydroxide group to a carboxylic group. Yes, Lily, that's right. And Tadashi, does it matter if the OH gets placed on the last or the first part? Yep, it does. If I have the OH and I put it somewhere else on here, Tadashi, that's not at the same side as the double bond O, let's say I put the OH over here. It's not an organic acid then. It becomes just something that has an OH at the end and a double bond O at the other end. But the thing is, Tadashi, it's going to go on the same side. And here's why. Because of that O pulling a little bit, this bond to a H out here, remember there's an imaginary H out here at the top. That bond becomes weaker and it's the likely spot for another OH to join. So Tadashi, it's more likely it's going to join out here and less likely it's going to end up somewhere else on the molecule. Now, if your question, Tadashi, is could I put the whole thing on this end or the other end, of course, that doesn't matter. If you turn this in your mind, ready? Pull it out, turn around. Well, now then this would be at the other end, so that doesn't matter, Tadashi. I could draw it first on my paper, or I can draw it last. It's the same molecule, if that's what you need. Good. I got some other questions. And let's see what Isabella has to say. Okay, the question from Isabella is, how do I know if it's polar or non-polar? The short answer is to look at a periodic table, Isabella. If I get 2 atoms bonded and one of them's really close to F and the other's further away, it doesn't have to be that far away. Then I'm going to get a polar bond. Like if I have F connected to P, then the electrons are going to be more pulled to F because we said F is more electronegative. You might remember that from another day. If my whole molecule is not very symmetric, then Isabella, I'm going to get something that's polar. Here's what I mean. Let's take an easy example, Isabella, and I think you'll see what I mean. What if I have this, F, F? Well, they both are pulling that. They're both very electronegative, both Fs, but they're pulling with equal amounts. So nobody wins. So this sucker is nonpolar. Now let's take one we had in a homework assignment, HF. All right. F pulls the electrons way more than H. So this side is way more negative, and this side is more positive. That's not a temporary dipole. That's a permanent dipole. So this thing is polar. Polar. Remember, in chemistry, it doesn't mean it's cold. It means it has a dipole. As a dipole, an electrical dipole. Two poles, a negative side and a positive side. So, to be honest, if I look at something like this, we'll have to learn this as we go a bit, Isabella, but if it had an OH at the end, that would be a bit polar. But if it's just a double bond O, it's less polar. Why? Because there's no H there that's acting as something that can give up its electron. There's only an O out there looking for electrons, cruising around, so to speak. Okay. I hope that helped a little bit. We'll have other stuff that we'll talk about being polar and non-polar, Isabella, including things like saturated and unsaturated fats. And then we'll review again polar and non-polar, I promise. Priya, let's see what you got as a question here. Could you repeat what a carbon chain with a double bond O on the middle is called? Is that a secondary alcohol? It comes from a secondary alcohol, Priya, and it's called, I'm going to hold up my sheet and maybe we can see. There's where we did that. Except my writing's so sloppy you can't read it. It's called a ketone. So here's how to spell it. So if I got a ketone, oh man, ole preole. I hope I spelled it right when I spell it to you. C-E-tone. Ready? So a ketone has got a double bond somewhere in the middle. All right? So it's going to look pretty like this. Doesn't matter where in the middle. Okie dokie. So that'd be a ketone. Ketones. Ketones. This would be, oh man, what would it be? Butanone. That would be the German word. In English, probably we'd say like butyl ketone or something like that. We're not going to do a lot with ketones, so don't lose any sleep over them. But that would be a ketone, right? Sounds like a singing group. Okay, everybody all right so far? You've done pretty good. Let's review a little bit the last few minutes, okay? All right, so let's talk about our vocabulary. And the vocab we're going to use over and over, so it's good to learn it. And I know you got a lot today, didn't you? So here we go. Here's our vocab list. Okay, vocab. If I got an OH on a molecule, we call it a hydroxyl group. You could call it a hydroxide, but to be honest, in the world of organic chemistry, we more than often call it hydroxyl group. It acts a little differently in organic molecules. Frankly, it doesn't come off as easily. If I have a hydroxide, like NaOH, it tends to separate in water and become a very strong base. So hydroxyl group, that's just an OH somewhere on the molecule. I'll take your other question in a sec here, Magdalena. And then if I got this thing, if I got a C double bond O, that name of that sucker is the carbonyl group. Okay? And finally, the last one today is if I got a C double bond O, OH, and that's the one with the long name carboxylic group. Okay. You might say, Mr. Weiss, that's all pretty complicated. It is, but we're going to use them over and over so they will become like friends of the family. Okay. Hey, hydroxyl group, how you doing? Come on over. Oh, looks like I got a carbonyl group on that one. All right. Okay. And then this one we'll use often in reactions, carboxylic groups. We're going to learn how to make esters and maybe someday do a lab on that if I ever see you again. Let's take a question or two. You're welcome, Priya. You're welcome, Isabella. Magdalena. So when a primary alcohol gets oxidized, we get an aldehyde, right? And when a secondary one is oxidized, we get a ketone. Yeah, and I do this sometimes. Magdalena, there's no Y in ketone. If I wrote it wrong the first time, everybody, I'm really sorry. Ketone has no Y in it. Why I keep putting one in there through the years, I don't know. Your teacher's going senile, okay? It's spelled like this, ketone, all right? If I put a Y in it, get rid of the Y and don't ask yourself why. Just get rid of it. So sorry if I misspelled it. That's how you spell it, okay? All right. Any other questions from you today? Well, that's a lot. That's good. We've done good, people. Let's see if there's any other questions. And if not, I want to talk to you through our last couple minutes through this sheet. My people, can I ask if I sent you this sheet? And it says alcohol, and it says consumption of alcohol 1. Did I send you that yet? I think the answer is no, but I'd like to know from one of you. Consumption of alcohol. Do you have that yet? Lily says no. Can someone else verify that? Not that I'm doubting you, Lily, but so you've not gotten that consumption of alcohol one. Thank you very much, everybody. Good. I will send that to you. I want to talk to you a little bit more about it, but I've got a question or two. Would an aldehyde be polar? Magdalena, it depends how long the chain of C's is. If the chain of C's is pretty long, it'll be nonpolar. And we're going to find that out. Well, we actually talked about that already. If it's really short, Magdalena, well, let me think about that. No, it's pretty much going to be nonpolar. Aldehydes are pretty much nonpolar preservants, and ketones are nonpolar solvents. Like if I have fingernail polish, which I don't usually wear, but if I try and wash it off, it doesn't wash off. Why? Because it's not polar. Water would wash off the stuff if it was polar. Okay? But if I take fingernail polish remover, acetone, and I dip my finger in that, the acetone is nonpolar and it dissolves the nonpolar fingernail polish on my finger that I don't use. Okay? All right. Yeah, so every organic acid, Lily, has a carboxylic group. And sometimes chemistry teachers get sloppy and they talk about the the they talk about the group being the acid. Like, oh, we take a carboxylic group and we add it to, well, they take an acid that contains a carboxylic group. I'll try not to be sloppy, but sometimes I am. But yeah, every organic acid has a carboxylic group. Yeah? Okay, so I'm going to send this to you, consumption of alcohol. I think I'm going to let you read the rest of it. I might assign next week a couple of questions on the next page. Probably not the whole thing, but it's kind of a cool sheet. It's translated from the German. So you kind of get an idea of the bodily effects on us. We started this and then we didn't get very far. Remember we talked about promil and percent? Like if I had 0.5 promil, it's 0.05%. And yeah, we didn't get to the 2%, 3%. No, sorry, 0.2%, 0.3%. But here's a little thing. If I get up to 0.4%, which is not much, not 1%, not 4%, but 0.4%, I have that much alcohol in my blood, I'm probably unconscious. So if you know anybody who's drunk that much and was unconscious, probably they hit 0.4% of alcohol in their blood. Not a lot. If I have somebody who has 0.5 or 0.6% in their blood, they're on their way to being dead. Okay, so too much alcohol is a poison, as it turns out. So you got to be careful. This will tell you about that. I'll send that to you, and you can read that maybe as an assignment next week. Okay, but it's quarter after, and I'm going to call it good. I'm going to say happy Friday. I got to get to school and do my 11th graders. So I will say farewell to you. One last question from Magdalena: how much alcohol do we naturally have in our body? None. Unless you drink it, it's not in your body. Although if I eat a lot of potatoes, I've heard it can ferment a little bit in your stomach, but I don't know if that's really true. Thank you all. Have a good weekend. Stay healthy. Maybe I'll see you soon. Maybe after Easter, huh? Bye-bye.